Okay guys, in this chapter we're going to talk about angles of polygons and parallelograms. So we first want to talk, just start out with angles of polygons. Now, we know that whenever we have a polygon, just to sort of review, a polygon is some enclosed figure with some sides and angles. It can have many sides. It can have 10 sides, 4 sides, 3 sides. So polygons must be enclosed and they must not have curved lines. Okay, so triangles are polygons, quadrilaterals are polygons, pentagons, all of those are polygons. And so many of the shapes that you've worked with in two-dimensional geometry are polygons. Now we want to talk a little bit about, let's say, okay, let me draw some polygons here. Okay, so I've just drawn here a triangle, quadrilateral, and a pentagon. And so basically, what we first want to deal with here is what we call the sum of the interior angles. So sum of interior angles. Okay, and what that means is basically, what do all of these angles add up to? Okay, so if I give you a 12-sided shape, what are all the angles going to add up to? So I can draw, for example, I think maybe many of you know a triangle or a quadrilateral, but what if I gave you an octagon? Okay, how many? And you wanted to add up all of these angle measurements. Well, what would the answer actually be? So before we get into that, we basically have to know two facts. First of all, we should know that the degrees in a triangle add up to, there are 180 degrees in a triangle. Okay? And that's going to be sort of the base, the foundation of this sum of the interior angles. Okay? Because from there, in any quadrilateral, you can make triangles. So many of you know, for example, that a quadrilateral has 360 degrees in it, right? And the reason that is, or the reason we can show that, is because basically quadrilaterals, every quadrilateral has two triangles, and we know that a triangle has 180 degrees. So here's 180, and here's 180. Okay, so 180 plus 180. You know, we would have this plus this plus this plus this plus this plus this. That's going to be 360. So this green line that I've drawn here is called a diagonal. It's called a diagonal of a of a polygon. So you can draw diagonals in all polygons. So for example, we can draw in a pentagon. We can draw two diagonals. Okay. So with that, you can know that this is 180, this is 180, this is 180. Okay, so since all three of those are 180, again, let me sort of show you visually what this looks like a little bit better. We have this angle plus this 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 plus this. So those angles, those are all going to add up to 540 degrees. Okay, so you might see a pattern here. We have 180, 360, 540. Okay, you see a pattern developing here. And basically, if you can think about, again, getting back to our octagon question. All right, let's say we have diagonal, 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 and diagonal. Okay, so the number of triangles, and again, this is going to be 180 times 1, 2, 3, 4, 5, 6. Okay, so 180 times 6, 180 times 6, 0, 8, and 1080. So all of those angles add up to 1,080 degrees. All right? So basically, what you guys notice here then is the number of triangles. Okay, the number of triangles that are in any polygon. So the number of triangles is n minus 2. So the sum of the interior angles is n minus 2 times 180. Okay, so let me just explain where this comes from. This is the number of triangles. This is the number of triangles in any polygon, okay, with the diagonals. And this is the degrees of a triangle. Okay, so basically we're just dividing up any triangle, and we're dividing up the triangle with we're dividing up the polygon with diagonals to make triangles. So this is how many triangles you'll have, and these are the number of degrees in every triangle. So n minus 2 times 180. All right, let me circle that. Okay, so that's our first equation. And we're going to look at examples in further videos, but this will be the one equation that one of the equations that we're going to look at in this video. Okay, second, I want to look at the sum of exterior angles. Okay, so the sum of the exterior angles. So let's come back here. You recall in geometry we have things like exterior angle theorem. All right, so we have words like that. So we might have a decent idea about what exterior angles are. Basically, let me explain. Okay, so an exterior angle is if you extend these lines. Okay, so we're just extending these lines. Okay, and this line is a little bit off. But basically, the exterior angle would be the angle that is supplementary with the interior angle. So let me write down, there's angle 1, angle 2, and angle 3. So angles 1, 2, and 3 are interior. Okay, so angles 1, 2, and 3 are interior. So you have to think about the linear pair that is formed. And so angles 4, angle 5, and angle 6, angle 4, 5, and 6 are exterior. All right, so angles 4, 5, and 6 are exterior angles. So what is the sum of these angles? Okay, or what is the sum? You know, we can apply this not just to a triangle, but to all polygons. Okay, so we have all of these angles here, and we want to figure out what the sum of the exterior angle is. Well, we know that there are 3 linear pairs here. 1 and 4 is a linear pair. 2 and 5 are a linear pair. 3 and 6 are a linear pair. So if we add up all of these angles, 1 plus 4 plus 5 plus 2 plus 3 plus 6, that'll give us all the angles. And then if we subtract out the interior angles, then we're gonna get the sum of the exterior angles. So let's do that here. We know that this is 180 plus 180 plus 180. Okay, so I'm going to come over here. We have 180 times 3. Okay, and so that's for the linear pairs, right? 1 and 4, 2 and 5, 3 and 6. And then we have to subtract the interior angles. The interior angles is 180. So this is going to equal 360. Okay, if you do the same thing, so let's see if there's a pattern or if anything changes here. Okay, if we do the same thing here, let's make our interior and exterior angles. Okay, so we have here. All right, so if we have angle 1, 2, 3, and 4, all right, then 5, 6, 7, and 8 are going to be, again, interior, exterior. So 1, 2, 3, and 4 are interior, 5, 6, 7, 8 are exterior. So what is the sum of these? Well, we're going to use the same logic, okay? We know that 4, so 180 times 4 is all of the linear pairs. So 180 times 4, 1 and 5, 2 and 6, 7 and 3, 4 and 8. Okay? We know that all of those is the sum of all the angles minus the interior angles. Well, we know the interior angles right here is 360. So that equals 360. Okay? You can keep going on and on and on like this. We're not going to spend that much time. But the sum of the exterior angles is always equal to 360. No matter what. Even in an octagon, in a 20-gon, in a 100-gon, of course, the exterior angles, if you add all of them up, then they all add to 360 degrees no matter what. So this is sort of the foundation, at least of half of our chapter, the angles of polygons. And so we're going to use these, see how they work in different problems, and then we'll go from there. Thanks for watching.